Alright, today we're going to learn about surds and how to manipulate them. By the end of this video, and after you've taken some notes, done some exercises, you should be able to tell me what a surd is, how to simplify surds, how to perform operations with surds, that is, add them together, multiply them, divide them, that kind of thing, and all of the above, but with letters rather than numbers. So let's get started. In junior maths, when you end up with something like root 50 in the course of your calculations, and it might have been in a Pythagoras problem or something like that, it might have looked like this. If you wanted to get what x was, you would have just plugged root 50 into your calculator and ended up with 7.07. There would have been a bunch of other stuff afterwards, but you would have just said 7.07, 2 decimal places, done. That's correct, but it's not exact. It's just an approximation. There's another way to deal with root 50, and it goes like this. If you end up with root 50, you can write it as the square root of 25 times 2, because of course 50 is 25 times 2. You can split it into root 25 times root 2. You can simplify root 25, it just equals 5. And then you can recombine. This is called an exact value. Now, what is a surd? A surd is this bit. A surd is something that when you simplify it as much as you can, you still have that square root sign, or a cube root sign, or a fourth root sign, or whatever the case may be. So for that reason, something like root 9 is not a surd, because it equals 3. But something like root 5, which can't be simplified, that is to say, it can only be simplified into a decimal approximation, this is a surd. So something is a surd if it can't be simplified without getting rid of that symbol there, the square root symbol, which is incidentally, it's called a radical symbol. Anyway. So, the basics. In order to simplify surds, like I did above, you need a knowledge of squares and square roots. So you need to have these things clear in your head. 2 squared equals 4, and that this is equivalent to the square root of 4 being 2. 3 squared equals 9, and this is equivalent to the square root of 9 being 3. 4 squared is 16, and this is equivalent to the square root of 16 being 4, etc. Okay, this continues on. So you need to know your square numbers, and you need to know the square roots of those square numbers. Now, in order to simplify surds, the main thing you need to do is find square factors. Okay? So, let's say we want to, example 1, simplify root 20. Okay? Step 1, we break the number up, taking out square factors. Take out square factors. So root 20 becomes 4 times 5. This guy here is a square factor. Step 2, we split the surd. So root 4 times 5 becomes root 4 times root 5. Step 3, we simplify where possible. So root 4 we can simplify to 2. Step 4, recombine. So 2 times root 5 becomes 2 root 5. Just like 2 times x becomes 2x. Easy peasy. All right. Let's see if we can do some other examples. Example 2. Let's simplify something like root 32. Okay. Have a think about what square factors 32 has. 4, maybe, definitely, that is to say. But you want the biggest one, okay? You want the biggest one. So I'm going to say 16 times 2. Okay? You can split it. 16 times root 2. Simplify. 4 root 2. And recombine. Now, I hear you asking, what if you did take out the 4? Would you get the same answer? Well, yes, you would. Let's have a look. I'm going to do it here in red. We can write this as 4 times 8. But then the thing is that 8 can also be split. 4 times 4 times 2. Split. But we split into 3 now. So even if you didn't get the biggest one in the first place, as long as you do legit algebra and follow the rules nicely, you'll end up with the correct answer. 4 root 2, just like before. Easy peasy. One more example. Root 75. What square factors does 75 have? Have a bit of a think. And then you might think to yourself, oh, of course, 25 is a square factor. So let's do that. 25 times 3. Split. Simplify. Recombine. Done deal. Easy peasy.